In the previous video, we were taking a formula, an example of a literal equation, and solving it for a particular variable. And that was it. It was just basically rearranging the equation. But what our goal here is to take that equation and rewrite it in terms of another variable. And this idea of in terms of that vocabulary right here, which is super common on a test like the SAT and the PSAT, I want to make sure that you have a firm grasp of what is expected. Okay, so usually when we say in terms of, it is just indicating what variables should be over on the right-hand side of the equation. Let's look at the area formula of a circle right now. What is it that you need to know in order to calculate the area of a circle? You need to know the length of the radius, which means that the area formula is in terms of the radius. It also means that that radius is the independent variable, and the area, depends on what value you put in for r. It's the dependent variable. Okay, but what we want to do, as you'll see in just a little bit, is maybe I don't want it in terms of r. Maybe I want it in terms of another variable like diameter, or perhaps like the circumference of the circle. And we're going to do that by substitution, okay? So once again, the in terms of is going to denote which is the independent variable that we want on the right side of the equation, and we're going to get it there by essentially solving a system of literal equations. So what are the methods that you could use to solve a system of equations? Well, we've got ourselves graphing. We're not going to graph these equations. Do you want to graph this guy right here? You want to graph a equals pi r squared? I mean, you could if you thought of a as a y and you thought of the r as the x. You could, but no. Or you could do substitution or elimination. Elimination is usually reserved for examples of linear equations, not necessarily literal equations. So substitution is going to be the way to go. Here, let's take a look at an example. Right here, write a formula for the area of a circle in terms of its circumference. All right, so I'm going to break this down so that whenever you see a problem like this, it's no sweat. So you're going to start with the formula it tells you to write. It tells you to write a formula for the area of a circle. Highlight that. And I'm going to write down a formula for it. A is equal to pi r squared. Right now, this formula, as we expressed earlier, is in terms of the radius. You need to know the radius in order to calculate the area. But we want it in terms of the circumference. And what this means is that our formula is going to end up looking like this. A is equal to, there's going to be some stuff on the right side of the equation, and that stuff needs to contain a c, and only the variable c. You can't have an r in there too. You can't have a d in there. It says that it has to be in terms of circumference. It is now going to be the independent variable that we would use in order to solve for the area of the circle. So how do I do that? Well, I need to replace or substitute something in the place of this r so I can get rid of it. So I need another equation that involves circumference and r. And that formula is c is equal to 2 pi r. Well, sure, there's another formula which is pi times d, but I'm not going to use this one because these two equations right here don't have anything in common. I can't get rid of the r if this thing only has a d. So we're going to get rid of it. Mark it out. And then I'm going to highlight the fact that the two equations that I'm working with have an r in common. And that's good because that's going to allow me to substitute it. I just now have to make a decision. Which one of these equations am I going to solve for this r that they have in common? And the answer is you have to leave the area formula alone because that's the formula that the question's asking you to write, which means we're going to take the circumference formula and solve it for r. And whatever we get, we're going to plug that or substitute that in the place of the r. Okay, so here's where those skills, those previous skills came in of solving a literal equation for a particular variable. We're going to solve the circumference formula for r. R is being multiplied times the 2 and the pi. That's all one kind of operation, so we can get rid of it at the same time by just dividing the 2 pi over to the other side. So that is going to look like R, flipping this thing around, is equal to C over 2 pi. Now I'm going to take the quantity 2 pi. Actually, let me switch some colors here to make this nice and colorful. I'm going to take the quantity C over 2 pi, and then I am going to replace that or substitute that in for R in the area equation. So here's what my new equation is going to look like. I have A is equal to pi, and think of this R right here as a placeholder. So I'm going to put some parentheses there, placeholder. And where R used to be, I'm going to replace it with C over 2 pi. And I can do that because that is equal to R for a circle. C over 2 pi, and then I have to square it because it's R squared. And if you left your answer just like this, perfectly acceptable. However, if this is a multiple choice kind of question, like something on the PSAT or the SAT, you just have to do some algebra, possibly to make this answer look like one of their 4 answer choices. Okay, so let's just kind of simplify here. I've got a fraction, a quantity that I need to square, which means that I'm going to square both the top and the bottom. So I have A is equal to pi c squared over, now the 2 is going to be squared and the pi is going to be squared, so that should be 4 pi squared. Okay, here, let me ask you a question. I'm going to insert another page. Let's turn this into numbers so this next step makes sense to you numerically. Let's say that I had the number 5, and then I'm going to multiply the number 5 times the fraction 2/7. Just making up some numbers here. How do you multiply 5, a whole number, times a fraction? Well, traditionally what you do, of course, is you put this 5 over 1, because 5 divided by 1 is just 5, and then you use, the technique that you learned how to multiply fractions, which is top times top and bottom times bottom, to get 10 over 7. And notice that what happened essentially is that you only multiplied that whole number times the top. And you can kind of shortcut this because the 1 is being multiplied times 7, and it's as if you just didn't do anything. What I mean by that, if I come back up here to this previous equation, I want to simplify this so this is a single fraction. So this pi is going to be multiplied times this fraction. Where's it going to go? Well, just like this 5 ended up top, so will this pi. And again, you could, if you wanted to, put that over 1, and then you can see that that pi is going to multiply up top, and then the 1 is going to multiply on the bottom and not do a whole lot. Okay, so this simplifies to pi c squared over 4 pi squared. And then I'm going to do one last thing because I just looked at my answer choices, my hypothetical answer choices, and I saw that this wasn't it. But there was something pretty similar, and that was the fact that we have a shared factor of pi on both the top and the bottom, and I'm going to get rid of it. I am going to divide the top and the bottom by pi, and what I usually do is just cross out the 2, because this pi squared is essentially pi times pi, and you just divided one of those pi's away. All right, what's the final answer here? It should be A is equal to, on the top of the fraction, you only have a c squared left, and on the bottom, you have 4 pi. So this equation is now the area of a circle in terms of its circumference. In other words, the only thing that you need to know to find the area of a circle is the value of its circumference. Then you'd square it, and you'd take that whole quantity and divide it by 4 pi. All right, let's give you a few of these to practice here. All right. So right down here, you can see on the first one, write the formula for the area of a square in terms of its perimeter. Very similar to what we just did, but this one is actually a little bit less complicated because there's no pi in it. All right. Number two, slightly different, show that the perimeter of a rectangle can be written as P is equal to 2A plus 2W squared over W. Now this one's strange because you already have your answer, and there's a couple of ways that you could tackle this. Let's see what you come up with. Can you take the area formula, no, the perimeter formula for a rectangle, and transform it in some kind of way to make it look like this? And then the last one here, number three, write a formula for the area of a right triangle in terms of its base and its hypotenuse C.